Start now.
Alright, we're group 12 and we did engine number 23. I'm Cameron, this is Gavin, this is Blake, and this is Reed. We'll start out with the crankshaft. I started out with drawing circles and extruding them to form the threaded end of the shafts. I then created a box on the end and extruded that on the top axis of the shaft to create the slot. I then drew the counterweight and the threaded end tower and extruded boss out to create the counterweight. This I thought was going to be the hardest part and ended up not being too awful. I then drew a triangle on the side axis and mid-plane extruded cut it to cut out the diagonal piece on the tower. I then drew the threaded end tower ring by using a slot and then used a half circle on the bottom to complete the circle. Then extruded it towards the threaded end shafts. I then drew and extruded the rod journal. And then I copied and did the same thing on the non-threaded end. And then to create the cutout on the non-threaded end counterweight, I drew a triangle on the side axis again on the bottom of the counterweight and drew a midpoint line through the axis of the two shafts and then revolved cut around the middle axis to get the angled cut around the whole counterweight. And then I also drew a box on the side axis and mid-plane extruded cut it to create the slot on the non-threaded tower. And then I also used the mid-plane extruded cut to create the two circular slots on the non-threaded end shaft. I used the fillet feature to add the rest of the fillets to the crankshaft, and then I used the thread feature to thread the threaded end and the inside holes on both ends. And these are the different views. And Gavin went on to talk about the camshaft.
Alright, so I had the camshaft. Ready to play for me? Alright. First I made the rod. I did it all as like one big assembly, so made the rod and the individual pieces to go onto it. So I made that first. I did that by like creating sketch, and then it was just half of it and doing a revolve. You go ahead. And then I made the first cam, and right here I did a circle, extruded that. Or no, I did a circle, and then I had a 3-point tangent arc connecting the big circle to a little circle out at the tip, and then did an extrude, and then extruded 2 circles off each side to create the cam. And the second cam, I used the same exact one from my last piece, but I just changed the extrusions off the face of it and made that. And I have a extruded cut in the middle of all of it for the rod to go through. And then the gear, which still has work to do, I went in the toolbox and just made a gear out of that, and then a boss extrude for that circle, and then did a extruded cut in the center of it for the rod to go through. But it still has more work to go. And also, I have 2 pieces which are still undergoing SolidWorks that haven't been added in yet. But here's Blake. He's going to talk about the connecting rod.
Hi, I'm Blake Holloman, and I was assigned the connecting rod. So first we have the half circle part, which fits directly with the main part of the connecting rod. So this is the circular side of this half circle, and each side was different geometrically. And I thought this side would be the hardest because of the curves and the circles, but it turned out to be actually the easiest because it was the fastest to do. The other side took a little more time with the cuts and the fillets I had to do to make the edges not so sharp. because they have smooth edges now, as you can see. This is the filleted arc on the back side of each side of the back side of the half circle. And this is the hole through the trapezoid feature, which connects directly with the main part of the connecting rod. This hole is very important as to get the connection right. And this is the main part of the connecting rod. It took a little more time to make because it was bigger and included many more features. And this is the trapezoidal extrude, whereas the half circle had the trapezoidal cut. And this is the assembling of the parts, where you can see as it fits in the trapezoidal shapes and everywhere else too, and lines up. And this is the connecting rod assembled, just another picture. And here's Reed Clark with the piston and gudgeon pin.
Alright. Originally, in order to make my piston head, I tried to make that as one cylinder, did a circular revolve, and I extruded it. But then I couldn't figure out how to make these cuts on the circular side. So I went ahead and scratched that, and I redid it as a rectangle with these little indentions in it. Then I did a revolve around this axis, so that allowed me to make that shape. And so then I had to make some of my main cutouts to get the general shape. I cut out all of that. I did a through the whole thing to make the hole for the gudgeon pin. I cut out the bottom to make the exterior, and then I cut out the back end. So at this point, the part is symmetrical still. Next, I had to add some more detailed pieces. So I made these extrudes. I did a circular extrude through there, another circular extrude through there. I made these rounded edges around there. Now I added some of my final cutouts of my fillets. I had to cut out there, cut out right there. I had to cut out the same on the back end. You can tell that this hole is smaller than the other hole, because that way the gudgeon pin goes through there, but it's also blocked. So that way you don't just push the pin all the way through the part. Here's some pictures of it. Gudgeon pin. So what I did with the gudgeon pin, I found the easiest way to do it was, originally I tried to make a cylinder and extrude that, but I found it difficult to get that little edge cut. So what I did this time is I made another rectangle. I did a rectangle with little slanted edges, and then I revolved that to make a circle to get the shape.
And then our prototype connecting rod, we did more of a H-beam type shape, like how the beams are in race cars. And it's more, instead of having the cutout on the front plane, it's on the side plane, which gives it more strength and prevents bending.